Drag, who we did a video on today, in his after show, all he had to say, so he didn't address any of the testable predictions on mutation rates, absolute mitochondrial DNA differences, the fact that you can read the history of civilization, the history of humanity from the map. Nothing. All he said was, oh, well, you know, M and N came from L. That debunks them. What do you think about that, Jeremy?
That's the response that we got from the others, correct? A few months ago.
It's sad. It's like, is that all they got?
Did you told them our rebuttal to that?
Well, it's funny because the guy I was debating, he didn't have any rebuttal. He wanted evidence for biblical creation. I gave it to him in testable predictive form, but he wouldn't actually engage the data. So it was in an after show later. They were doing damage control. That was the argument. He said we already addressed it. Do you want to go over the rebuttal real quick to that simply?
Yeah, sure.
These are, I think it's 1,000 individuals, okay? The tips, they're the individuals. Here's the 3 haplogroups right in the middle. You notice the lines, you can see my mouse. The lines joining them are short, so very little DNA differences. The lines radiating out, okay? So here's your African branch from L, the L root. Those are long, indicating larger genetic differences, but they all go, there's subgroupings here. That's where we read the history of humanity. But they all go back to 3 major groups, right? These demonstrate that it's, you know, a time of fewer generations. Noah's 3 daughters-in-law.
Pre-flood.
Noah's, yeah, and of Shem, Ham, and Japheth, obviously. But his only argument, which is funny, they won't address the data, they won't address the predictions. They'll say, well, M and N came from L. What would you say to that, Jeremy? We have found a single dispersal of all people in the relatively recent past, traveling in small people groups into uninhabited territory through the Middle East. They call it the Out of Africa story, but these are all biblical-based predictions. I want you to look at this tree. You can find this in the book Replacing Darwin and in the work of Dr. Nathaniel Jensen. This is several hundred human individuals. The tips of these branches represent human individuals. Distance of lines, the very long lines would be lots of DNA differences, and short lines would be almost none at all. What do you notice about this tree? This tree represents various people groups around the globe. Many of these lines come together as 3 major nodes. This is a fact that evolutionists even acknowledge. These are the 3 major haplogroups. How much longer do I have, James?
Got a minute, 20 seconds.
There are 3 major groupings and subgroupings. Length of lines connecting the groups are short, and lines radiating out from the groups are long. Reading scripture, we know our maternal ancestry goes back to Eve. Population would then grow and shrink to 8 at the time of the flood, and then grow again momentarily, ending with the splitting of people groups at the Tower of Babel. 1 Eve in the beginning. Population then shrinks to 8 people. Noah, Noah's wife, 3 sons and 3 wives of Noah's sons. 3 boys get their mitochondrial DNA from mom, and then it ends. Genesis 9 says that these 3, the entire world was repopulated. We get our mitochondrial DNA from their 3 wives. The history of humanity is in our genome. What we know about mitochondrial DNA of humans fits the 6,000-year timescale, explains the 3 major haplogroups and the relative differences between pre- and post-flood humanity. We're making testable and falsifiable predictions. For example, the stamp, the tree that I just showed you, it contains the stamp of the history of civilization, the Roman Empire, Persian Empire, and Greeks.
Group L, which is largely considered kind of like the progenitor, and then from L you get M and N. What I've actually caught standing saying is that L, M, and N all stand laterally to one another. Not that L is a progenitor to M and N, which goes against every haplogroup like illustration and anything that I've ever seen.
Wow.
Okay, Drag has a point that the M and N came from the L based on his worldview, and
Right.
even based on this, and also based on this map. This map was generated and created by Dr. Nathaniel Jensen for over 1,000 individuals spread around the world. Okay, it's a subset, but it's a good subset, which makes predictions. Now, like I said, Drag has a point. because there are three green green arrows there, right? And those three green arrows are the L, M, and N. By the way, the letter L is in the middle. It's the middle arrow, and the M and N are the other two green arrows. So as you can see, the letter L is what connects the M and N. Okay, like I said, the L is in the middle, and then the M and N are connected to the L. So when I look at this from an evolutionary starting point, yes, I would conclude correct. Drag is right. The L produce M and N because M and N are connected to the L because the L is at the middle of the M and N. Okay, but what Drag is not telling you is this. I don't know if he knows the data or he's being crafty or not. I'd rather believe that he doesn't know the data. I'll give him benefit of a doubt. If you're gonna base the starting point L, which is the starting point of M and N, based on what you said, based on this map, okay, he's wrong. You know why? Because the L, M, and N, based on this map, are close together. Okay, which means that their genetic differences are close to one another. Okay. Also, Drag's point is because the letter L, okay, standing for truth. Can you please direct your mouse to the African haplogroup? Yes, this is the L, right? Like I said, the middle arrow over there. And the L primarily are the L1s, L0s, L2s, which is this long African branch here, where standing for truth's mouse is. And because evolutionists believe that larger genetic differences, and they also believe that Africa is a starting point for human evolution, that is another point of drag, that the L is the starting point. Okay, so I'm trying to represent their position well here. So first, because the L is in the middle of M and N, okay, which connects M and N, that is why he said that the M and N came from L. And because their starting point is Africa, which is this longer branch, and this longer branch is directly connected to the letter L. So if I were an evolutionist, yes, I would say drag is correct. But like I said, based on this map, the LMN, as you can see, they're close together. The three arrows, they are close together, which means that their genetic differences are few. Okay, what needs to happen here is for Drag's argument to be true that the L came from M and N, the L has to show a much larger genetic differences compared to M and N, not this close. It must not be this close. The L should be distinct from the M and N. They should not be this close together. As you can see, these are the three closest and most distinct, okay, most distinct haplogroups in this haplogroup map. Okay, they're the most distinct, and they are the closest ones together. The rest are farther apart. Okay, they're farther apart and not close together, as you can see. Okay, for like I said, for what he said to be true, the L should be significantly should display much larger genetic differences from M and N. Okay, so that's it. And okay.
Well, and the thing is, he'd have to make, so for example, we're making testable predictions based off this map. So for example, is this the the most divergent of African people, like the Khoisan peoples, for example? There's actually been measured mitochondrial mutation rates predicted by Dr. Jensen. So there's a testable prediction based on the same rate that he used to derive the absolute mitochondrial DNA differences from the various species that have been sequenced. So someone like Drag, someone like the evolutionary community, they can go make the same predictions, but are they gonna? That's the question.
Let me completely destroy his argument. Let me finish. I think I have addressed the L connected to the MN thing that Drag stated.
Yeah,
Like I
absolutely.
said, yes, like I said, the L, M, and N should not be that close together. They're genetic differences.
Too
L,
few. Too few.
yeah, L, L's genetic differences must be much larger than M and N. Okay, it's okay if M and N's genetic differences are few from one another, but the L's genetic differences must be much larger than M and N. Now, regarding the African branch, because I'm sure Drag's point is the African branch too, because that's their starting point. The genetic differences in Africa is true. It's larger than the rest of the world. But young Earth creationists can explain why that is the way it is. We have different recombination rates. For example, we have the data that states that Africans marry earlier. So that
Yeah.
means that if Africans historically marry earlier, then more genetic differences, more mutations would arise because longer generational times, correct? That is why Africa is showing this amount of larger genetic differences. So given the two examples, there are more evidence to debunk why genetic differences in Africa are large. Yeah, it's large, but those were two of the five explanations. If you explain that in a young Earth creationist point of view, then this long African branch is not really that long. We can cut it up to somewhere here, beside the green, left side of the green, this green square rectangle here, somewhere there. Okay, that's theoretical. So we need more data. So he cannot use the out of Africa as evidence for the L starting point too. Okay, so we have debunked his argument from two angles, from two fronts.
So there's Eve in the beginning, one Eve, then the ancestry shrinks to what? You have 8 people, Noah, Mrs. Noah, 3 boys and their wives. 3 boys get their mitochondrial DNA from Mrs. Noah, and then it stops. Genesis 9, from these 3, the whole world was repopulated. We don't get our mitochondrial DNA from them, we get it from their 3 wives. So the fact that this then breaks into 3 with relative branch lengths that fit the relative time proportions seems to fit this biblical model. Short pre-flood times, those blue bars separating the 3 wives. Scripture doesn't say if they were sisters or more distantly related. And then lots of generations post-flood, those pink bars. So the structure and relative branch proportions and the absolute numbers, 3 independent lines of evidence, all fit what we see in mitochondrial DNA. Well, what about these subnodes? This model makes testable predictions. If we're all coming from those 3 nodes, and DNA differences are a marker of time, what we're looking at then when you radiate out from those nodes is post-flood time. In other words, the history of civilization. This model predicts you should be able to read the history of civilization off this tree. The history of the Roman Empire, the history of the Persian Empire, the history of all Greeks should be here. So what about this subnode? You see that it's coming off one of the major 3 nodes, and about halfway up it begins branching. Where do these, so the tips of these branches are individuals. Where do these individuals exist today? So let's put this together. I just hit the wrong button. Back up 1. And I didn't want to hit that, so let me go back this way. There we go. So you can see in terms of relative time, there's a branch that goes up from that node, then about halfway up that branch it splits off. So what would be half of 4,200, 4,500? It's 2,000-ish, 2,300 years ago. What happened 2,000-ish, 2,300 years ago around this section of the globe? The Roman Empire covered this section of the globe. So this is just the beginning of the sorts of studies we're doing. And in fact, if we had time, I could tell you some really electrifying results that we've been doing with the paternal ancestry, the Y chromosome. Rob Carter and I have been doing this, Creation Ministries International. We've been able to date the transatlantic slave trade. We're looking at the signature of colonialism. This is really working. It's really incredible. And that's not the only testable prediction it makes. Let's go back to the Khoisan peoples. Where are they? Way out there. I said the average number of differences is about 80 in Africans. The mutation rate has yet to be measured in some of these most divergent African people groups. The mutation rate I'm using has been measured in non-African people groups. So I would predict then, and this is a testable prediction, a falsifiable prediction, that the mutation rate will be 1 to 5 to 8 generations, perhaps faster, 1 every 2.5 to 4. So the prediction will be 1 every 2.5 to 8 generations. You can test that in the lab as soon as some Khoisan people give us their DNA. And these results, we're focusing on humans. These results are true of the other species in which we have measured mitochondrial DNA mutation rates. It's in the book chapter. I've got published papers on this. We don't have time to go into it. So, why am I only showing 4 other species? You think of the history of genetics. It's only recently that we've gotten DNA sequences. It's even more challenging to get the mutation rates. So that's why there's attrition. The number of species with DNA sequences is a lot more than the number of mutation rates.
Me, as someone who actually regularly goes to a lab.
So you can't answer my question